So we are doing the development of surfaces part. A hexagonal pyramid, base 30 mm side and axis 65 mm long, is resting on its base on the HP with two edges parallel to the VP. It is cut by a section plane perpendicular to the VP and inclined at 45 degree to the HP and intersecting the axis at a point 25 mm above the base. Now develop the lateral surfaces of the truncated pyramid. Truncated means all of you have known when the cutting plane is inclined at an angle with the base, it is called truncated pyramid. So draw the ground line first, then draw the hexagon by keeping two sides parallel to the base. Now the distance between ground line and the hexagon is not given, so you can take any suitable plane. Now to find the center, the centroid here, we have to join all the edges. So that is the position of the axis. Now from all the points, you have to take the projection lines up that ground line, isn't it? And also from the center. The axis height will have to be taken from the line, axis line drawn from the center line or axis line, whatever you may like to call it. Okay. So the axis height is 65 mm. Okay. So this is A, B, C, D, E, and F. Okay. We'll complete the solid projection first. I'm just drawing the zero point. So this is O dash. So this is A dash. This point, we have already known this. We have done the solid projections. So B dash, A dash. Next, C dash, E dash. Next is G dash. So we have obtained the front view of all the slant edges. Now you see, if you take the pencil compass and measure the length between OB and OA, they are different lengths, isn't it? But I need to draw by means of the radial line method, the actual length of the slant edge. Otherwise, our development method will be incorrect. So to find the actual length of the slant edge, what we need to see, we need to find that which edges the in top view, which edge is parallel to the XY line. Okay, so here the top views of slant edges are OA, OB, OC, OD, OE, and OF. But among all the slant edges, only OA and OD is parallel to the ground line or parallel to the vertical plane. OF, OE, OB, and OC are not parallel to the vertical plane or ground line, but OD and OA are both are parallel to the vertical plane, isn't it? So front view of those two slant edges will be the true length of the slant edge. Okay, so front view of OA is this much, or front view of OD is this much. So this will be the true length of the slant edge, either OA or OD. So both are same length. So by taking the OA measurement, okay, draw a arc, making center at O. We have drawn a arc. So this is the length. Let us say OA. Okay, this is the length OA. By measuring the OA length, we have marked a line, and then we have drawn a with the pencil compass. We have drawn a arc with the OA radius. Okay, so the base edges or the slant edges of the base will be here. So the side of the base is 30 mm. So by making center at here at points at 30 mm apart, so that point will be B. Then BC, this will be 30 mm. CD will be 30 mm. E will be 30 mm, and EF will be 30 mm. But we have to draw, and we have to take a point again. Why I am saying, you will automatically find it. Why I have drawn a double. Now join A to B. I'm drawing it with different line. Join A to B with scale, then join B to C, then C to D, D to E, E to F, and then F to F. Okay, I have joined A, B, C, D, E, F, and F A by straight lines. This curve will be like that actually. Okay. Next, join O to B, then O to C, O to D, O to E, O to F, and again O to A. Now we'll easily see the number of slant edges developed here: 1, 2, 3, 4, 5, and 6. Isn't it? So that's why I have taken a point twice. If I have finished, I would have finished that point at F, then the number of triangular faces will be 1, 2, 3, 4, and 5, which is not the case, as I'm developing an hexagonal pyramid. So number of triangular faces will be 6, 1, 2, 3, 4, 5, and 6. So my drawing is correct. So up to that, we have developed the surfaces of hexagonal pyramid. So this method is called, I'm writing this here also, radial line method. Radial line method. Now I have to develop the surfaces after a cutting being made. Okay. So a cutting plane will be there. So let me say that the cutting plane will be inclined at 45 degrees. So you have to take a point. Okay. At 25 mm above. Okay. Then through that point, on the y-axis obviously, you have to take a point 25 mm above. Then through that point, draw a 45-degree inclined line, and it is sent as it is given that incline at 45 degree to the HP. So the HP means angle will be seen at VP. So that line will be 45-degree inclined line, and you have to complete the section plane by making dark both the ends and drawing two arrows to show the viewing direction. Isn't it? So that is the viewing direction. The two arrows are drawn. Now I have to mark the points. Okay. So that point, let's say this is here, it is 1 dash, then it is 2 dash, it is 3 dash, then 4 dash, and again, so OD is 1, so 4 dash will be a lone point. Then here, this is the projection of C and E, so 2 points will be there. For 2 slant edges, 2 points will be there. Let us say this 5 dash, again for two slant edges we have 2 points again, 6 dash, and in the base it is also consisting of two slant edges, both AB and AF. So 1 dash comma 7 dash. Okay, now I have to draw projection lines from all the points. If you draw projection line from here, because this point is 1 and this point is 2. Okay. Then 2 and 6, draw projection line from 2 and 6. So that point will be 2 and this point will be 6. Again 3 and 5, draw projection line from 3 and 5. So this point is 3 and this point is 5 and 4. 4 will be on OD. Up to OD I have to draw. This point is 4. Now see here we don't have to draw the section line because it is not a solid anymore. We have to join the points so that we have found the points. Okay. We have to join the points actually so that we have found the points. Now we have to make the points dark, and we need to make dark these lines on this portion of the lines. I am drawing this by the date. I am making double lines actually. Okay, so these lines will be dark. Now all the lines, points 1 from 7 have to be marked here. Now how they are drawn? Just follow my method. Okay. So all the points will have to be projected on the true length. Okay, all the points. As 4 point is already on the true length, so just take the length between O dash and 4 dash and cut it on the D point. Okay, so I have taken by pencil compass the length O dash and 4 dash. Then we have cut as it is on D, so we have to mark the point on D only. Okay, so that point will be 4. Let us say suffix 1. I repeat again. As 4 is on the true length, as OD is the true length, as we have drawn all the lines with this length, this true length, so 4 point will be on OD. So OD. So we have drawn 4 1. Now 3 and 5 is not on the true length because true length is OD and the length of OC and OD, this length is less than that of the length of OD. So what we have to do, we need to project or need to draw a horizontal line up to the true length. Okay, please follow my method that I have to draw a horizontal line from 3 to 5 up to the OD line. Okay, now with the pencil compass take this length, not up to 3 to 5 but up to this length and mark it on the C. It is on the C and D. So take the length and mark on C and E. So on C we have 3 suffix 1 and 5. So this is 5 suffix 1. Okay. Now see 2 and 6, it is not on the true length. So just project the line up to the true length and take this length, not O2 to 6 because it is not the true length, because the length will be different. This length and this length is not same, but this length and this length is same. So project this point on the true length and take the measurement up O to this point and mark it. So 2 is on the B and F. So on B, mark a point 2 and the same measurement from O on F, mark the point 6. Okay, now 1 and 7. Now 1 and 7, the slant edge is not cut. Slant edge, the whole slant edge is omitted, isn't it? OA, the whole slant edge is omitted. But on the AB line, on an OF line, 1 and 2 are found, isn't it? On AB line and OA line, see 1. Sorry, this is 7. I have made it incorrect. This 7 points. So 1 and 7 point will be on respectively. 1 point is on OAB and 7 point is on AF. But this length you cannot project on the slant edge because it is on the baseline. So points 1 and 7 will have to be found in the top view only. Okay. So now take the measurement from 1 to A to 1. Okay, A to 1. Take the measurement. Take the measurement. So this one is on the AB line. So cut it here. That point will be 1, suffix 1. Another point remains 7. 7 is on AF. So AF is here. So from A, take 7 measurement, and from A, cut the point. So that point will be 7, 1. So after finding all the points, now you have to join the points with continuous thick line. 1 to 2, 2 to 3, then 3 to 4, 4 to 5, 5 to 6, 6 to 7. And these lines also. 1 to B, then B to C, C to D, D to E, E to F, and A to 7. And these also, because this line will remain 2 to B, then 3 to C, 4 to D, next 5 to E, then 6 to F. So hence our drawing will be complete.